Hey guys, and welcome back. So we are beginning into Unit 2 this week and into next week. And Unit 2 is all about transformations. And so this video is going to give you an introduction to translations, and it should be a continuation of what we did yesterday in class using Desmos. So by the end of this video, you'll be able to identify algebraic rules for translations and then translate given figures on the coordinate plane. So first off, there's transformations. We have examples and we have counterexamples of different types. So when you're thinking about a reflection, you want to think about a flip. Think about looking in the mirror and how everything is a mirror image. It's opposite of each other. So a reflection is a flip. There will always be a line of reflection, and we'll talk about that when we do reflections next week, but you'll be able to see that halfway point that everything goes through. So these over here on the right-hand side are all counter examples because this one just slid, this one kind of rotated, this one got bigger when it flipped. So they will remain in the same size and shape and orientation. It's just flipped and opposite. Rotation still keeps the figures to be congruent and the same, but they're going to rotate about a fixed point. And if you drew an angle between those points, the angle that is created would be the angle of rotation. The orientation will rotate around, but the figure will still remain the same size. So in these counterexamples on the right, we see that this one reflected, this one gets bigger, this one's just slid, this one kind of rotates, but it also kind of changes shape, and it's not about a fixed point, which makes it not a rotation. Down here, this last piece is translations, which are just slides. You're sliding it across someplace. The shape and orientation of the figure will stay the same. So all these on the left are examples. On the right, you see some counterexamples. This one, they change sizes. This one, it kind of rotates as it slides, and then this one just flips over. So you can see that those are not translations. On this next page in your notes, we're going to actually perform some rules. So this rule is telling us to take whatever our x value is and add 2, and then take whatever our y value is and minus 4. So I have created a little table here to help us. So we're going to add 2 to all of our x's. So for A, our x will become 4. For B, so we're adding 2. For B, our x will become 6. And for C, our x will become negative 3. Then we are going to minus 4 from all of our y's. So negative 2 minus 4 is negative 6. 5 minus 4 is 1. And 1 minus 4 is negative 3. Once we've created this table, now we can plot these points on our graph. So we found that A was at 4, negative 6. So we're going to go over to the right 4, down 6. And B was at 6, 1. So we're going to go over to 6 and up 1. And we're going to label that B prime. This is A prime. And C went to negative 3, negative 3. That's C prime. And then we'll connect. So you can see the shape has stayed the same, but you can see the pathway that it took of going down 4 and to the right 2. So we can see that that transformation is a translation. I'm going to go ahead and do number 3 because it's right here. This rule is telling us to keep x the same, but change the sign of y, or multiply y by negative 1. So I have created a nice little table over here for that one as well. So we are just taking our y's and timesing them by negative 1, which really is the same as changing the sign. So our x's all stayed the same, but the y's became the opposite sign. So if it was positive, it became negative. If it was negative, it became positive. And none of them are negatives. They'll just all become negative. 0 stays the same because negative 0 is the same as positive 0. So when we plot those points, we'll see that B goes to -3, -2. R goes to 0, -4. A goes to 3, 0. Doesn't change. And D goes to 1, 3. So we can see that this transformation, everything is the same amount away from the y-axis, or the x-axis rather, and except for A, which was on the x-axis. So this is a reflection. It's over the x-axis, but we're just going to think about it as a reflection. Looking at number 2, we see that our rule tells us to half the x and half the y. So I made a little table over here for that one as well. So we're just going to multiply by 1/2 to all of the x's, and we'll get -3, 2, and -2. And then we're going to multiply by 1/2 to all of the y's as well. Remember that multiplying by 1/2 is the same as dividing by 2. So we get -1, 3, and 2. So then we can come back over here and we can plot those points to see what happened. So the M is now at -3, -1. The A is now at 2, 3. And the T is now at -2, +2. Connecting those points. We see that our triangle has gotten smaller. So it was larger and now it's smaller, and that is what we call a dilation. It is the only transformation we'll talk about that doesn't create congruent figures. Look at number 4. Its rule is that we're just going to change the order. So it was xy, now we're going to change the order to be yx. So when we look at this table here, my new image is just going to switch the order of my x and my y. So I'm going to have 1, 4, 2, -1, and -3, -3. Going back to my coordinate plane, I can graph those points. So I'm at 4, 1 for 8. Oh, I'm graphing the original points. Whoopsies. The new one was 1, 4. 2, -1. And -3, -3. T actually stays the same. Oh, I went to the wrong place for O. 2, -1. Here's O. And there you have that. So this one actually is a reflection as well. All right, so let's get into some more information about translations and just take a deeper dive. So a translation is simply a slide. You're sliding it to a new position. The figure will keep the same orientation and size, and your pre-image and image will remain congruent. And we describe and write rules for translations in 2 ways. The first way is what we call the algebraic rule. And it just tells us that if t is at xy, it will map to x plus a plus x plus b. And that means that it moves a units right and b units up. In this other one, we have that xy maps to x minus a, x minus b. That moves the figure a units left and b units down. So if it's minus, it's left. If it's plus, it's right. with x, and plus with y and minus with y is up and minus with y is down. You can mix them up. This little arrow means maps to. So you're saying your original point maps to this rule, and that's where you just simply do what they've told you to do. So if we look at this example 1, on the coordinate plane, graph PQRS, where P is those are the coordinates. I've already graphed that there for us. We're going to use the rule XY maps to x plus 3, y minus 1. So the x plus 3 means we're going to move 3 units right, and the minus 1 means 1 unit down. If you want, you can make yourself a little chart to help you see what the new coordinates are going to be, or I think the easiest way is to just physically move them on the graph. So R is going to move 3 units to the right, so 1, 2, 3, and 1 unit down. So there's where R is going to be. And then Q will do the same thing, 3 units to the right and 1 unit down. So that's Q. And then P is 3 units to the right and 1 unit down. And S is 3 units to the right and 1 unit down. Another strategy that you can use is to move 1 point and then just count to the rest of the points from the original figure and how far they were away. So you can move R and then just count 3 from R to get Q, and then 4 down to get S, and just move about the figure that way. One thing that's important to note is that I've started, when I name my image, I name it with a little prime sign. So if I put A, that means it is the pre-image, the starting spot. When I use A prime, that is the image. That is the finish spot, or the new point. And when we get into this, pre-image, remember, is starting. That's just the original figure, and the image is the translated figure. So let's define that over here. So pre-image is original figure. Image is the transformed or transformed image. Okay, so these are some vocabulary words that you need to make sure you know. So whenever we want to write a rule, you always want to go from your pre-image to your image. So you'll always go A to A prime. So you'll always start with the A and end at the prime. So when we look at this example here, I'm going from A to finish at A prime. So I need to go 2 units to the left, so that's minus 2. And then I need to go 1, 2, 3, 4, 5 units up, so that's plus 5. So to write my rule, I would write that xy is going to map to x minus 2, y plus 5. This is affecting the x, and then the up is affecting the y. In the second example, we're going to go from A to A prime again. So this one, I need to go to the left 2, and I need to go down 6. So that's minus 2, minus 6. So you would write it as xy maps to x minus 2, y minus 6. Fairly easy to write your algebraic rules. Just remember that left and right go to x, and left is negative, right is positive, and up, down go with y. Up being positive, down being negative. Those same rules apply when we're using vector form. Vector is just taking out all the letters and using these little arrows instead. It's an arrow. It's pointed, not rounded, so you don't get confused with it being a coordinate point. And it's the exact same. If it's positive, it's right. If it's the first number is positive, it's right. If the first number is negative, it's left. The second number is positive, it's up. The second number negative is down. So when we have 2, 3, that means we are going to go to the right 2, up 3. Negative 1, 2 means we're going to go to the left 1, up 2. And 0, negative 2 means we're not going to go up or down or left or right any. We're just going to go straight down 2. We will work these other examples in class tomorrow. If you have any questions, please let me know, and I will see you tomorrow.